Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 8, 2025, about 2 days ago. The standout result is a simple post-training step that lifts GenEval from 0.73 to 0.90 and DPG bench from 80.93 to 88.15, while also improving image editing scores. The paper is titled, Reconstruction Alignment Improves Unified Multimodal Models, and as we'll see later, the implications for model training are quite significant. In short, this paper introduces Reconstruction Alignment, which uses dense visual encoder embeddings as rich prompts so unified multimodal models better align understanding with generation using a self-supervised reconstruction loss. Also, the authors shared a GitHub repo. Listeners will find a clear README with news on released fine-tuned weights and the ARCS4 Think, headline results and benchmarks, a small model zoo with parameter and score tables, planned TODOs for training code releases, and citation details. It highlights broad gains across multiple UMM backbones. On Hugging Face, downloadable weights and examples for Bagel RecA, Harman 0.5 billion, and Harman 1.5 billion parameter models, with inference snippets and benchmark gains for generation and editing. Alright, Figure 1 makes a simple point. The reconstruction alignment step lifts both benchmark scores and visual faithfulness, so instructions and edits match the images more closely. The left panels compare GenEval and DPG bench, where a 1.5 billion model with reconstruction alignment clusters near the top despite smaller size. The right panels illustrate stronger obedience to color and position prompts, and better edit preservation of identity and layout. Overall, the method delivers higher accuracy with modest compute. Alright, Figure 2 argues that dense visual embeddings provide richer supervision than long captions, so generation becomes more faithful to textures, layouts, and attributes. The left panel contrasts caption-based training, which loses detail because text is a sparse description. The right panel shows reconstruction alignment that feeds a visual understanding encoder embedding into the model and trains it to rebuild the image. That embedding is a compact semantic summary of the picture, which guides the generator more precisely. So, Figure 4 explains the core training loop. The model learns to rebuild an image from its own visual understanding, embeddings so understanding and generation line up. Dense semantic embedding means a compact vector that summarizes objects, layout, and attributes, which serves as a far richer prompt than text. The pipeline fuses that embedding with a light template prompt, runs the unified model and vision decoder, and applies a self-supervised reconstruction loss. At inference, nothing extra is required, so it behaves like a standard text-to-image system. So Table 1 quantifies the payoff. The reconstruction alignment step lifts a 1.5 billion unified model to top-tier scores across GenEval and DPG bench, which signals better faithfulness to colors, positions, and object counts. The table groups pure generators, unified models, and models trained with GPT-4o data, so comparisons stay fair. The reconstruction alignment row leads overall GenEval and posts an 87 on DPG bench, which rivals or exceeds much larger systems. Okay, 2 takeaways stand out. Reconstruction alignment uses dense visual embeddings as rich prompts, so understanding and generation finally point the same way, and it delivers big fidelity gains with tiny compute. The broader implication is practical. Smaller unified models can rival larger ones for generation and editing. That is it for the AI Research Roundup. I am Alex. Thanks for listening.